Hi, Barker Keith here from the Lake Travis Rotary Club. We're here at the Kilimanjaro Christian Medical Center in Moshi, Tanzania, along with the Tanzania Center for Orthopedic Technologies, and we got some fantastic news on what we've been doing for the last 3 days. Here is the finished first 3D printed artificial lower limb socket, and Mr. Brandon Sweeney and Mr. Jared Howell is going to tell you what's going on. Tell us what happened here, Brandon.
Yeah, so we have great news. This is the first 3D printed socket that has come off the printer here in Kilimanjaro Christian Medical Center, and it looks great. It came out with awesome surface finish. Looks like it's going to be an excellent socket to work with for Kidogo, and it looks like the design and everything came out the exact way that we intended it when we designed it. So this is really great news to see the first successful completion of this project, and this is anticipation of many hundreds, if not thousands, of more 3D printed limbs that will be printed in the coming months and years, especially with your help. So I'm going to show you what we have here. It just finished up, so we're going to look at how this print comes off, and I'll show you what we're working with here. So this is the finished socket. You can see it's got a nice optical clarity to it that will help with some of the fitment process. Jared can talk about that, but this is made out of polylactide. It's a strong engineering grade polymer that is in fact biodegradable. So this can be put in the ground and composted eventually, and it won't contribute to a lot of pollution, which is really another great thing for anywhere in the globe can benefit from that. So this socket is done, and we're going to do a few finishing items on it, and I'll let Jared talk about those things that we're going to do to finish it.
So Jared, to start off, where did that scan come from? How do we get to that part right there?
So we created this socket based off of a scan made of Miss Kidogo here.
This is Miss Kidogo's leg.
And so we took the scan earlier this week, and with that scan was taken on an iPad with a handheld scanner, and that was very efficiently and quickly taken. We then took that scan, which is a three-dimensional digital image, into a software program and then modified everything that you see here to create added pressure in certain areas, take away pressure in other areas where there's bony prominences, add in more areas here so that we could suspend the prosthesis over the femoral condyle. So all of this was done digitally, and then what was happened is that was transitioned into a specific file that could be 3D printed. It was plugged into the machine and then has been working non-stop without any supervision. Now, a couple of important things to notice on this particular socket is there's a few things that we still need to do. So one of the things that we'll do in this particular case is smooth down the top surface of the socket and open up the posterior or back side of the socket to make sure that her hamstrings and her knee can bend successfully. And then we'll attach the components below here. So it'll include what's called a prosthetic foot and a pylon. Okay, so it'll be attached here. Now this is relatively revolutionary in this process. Typically we would bond components onto the bottom of the socket to be able to attach the endoskeletal components to it. This is actually one of the first of its kind where we've actually put the component on and printed the whole thing out, which ultimately helps to save cost and effort associated with attaching those components. So I'm going to hand it over to my colleagues here at Christian Kilimanjaro Medical Center so they can take a look at it, see what they think, because they're ultimately the ones that will work with Ms. Kidogo.
So would you introduce yourself?
Yeah, I'm Mr. Longini Bazili Mtalo, Principal of the Tanzania Training Center for Orthopedic Technologies. It is a great revolution to see actually a 3D printed socket. Traditionally, we have been using plaster of Paris bandages, and then we get into the positive model. This most likely, if the project is successful, we may get away with all these procedures which we used to do. And in fact, with the service delivery we anticipate may also cut time for our patients who are coming to the clinics, because I think once it's still being printed, we can continue doing with something else, which is a great thing. So we are yet to try the fittings and see the outcome of this technology, and we are really looking forward to fit as many as we can. So thanks for Rotary for all this support which you have given us.
Would you introduce yourself, sir?
Okay, my name is Prosper Karan, head of orthopedic KSMC. I'm happy to see the technology at our department. Looking forward to fit more amputees and also to solve the problem for my staff and also to reduce the workload to our department. So I'm very happy, looking forward to support.
Tell us, Dr. Gunn, what this means for Rotary and the children of the world.
Well, as important as the science is, Barker, what's really important is that Rotary has taken on the task of being the distribution. So with the help of Baylor and KCMC, Rotary is going to take this science out into the community where people who don't have access to doctors can be reached and can be served. And when it's all said and done, at the end of the day, what it's really about is a precious child like Kadogo. Kadogo has been fitted here at KCMC since she was 3.5 years old. And because she's had excellent care, her outcome for the rest of her life will be very, very different. And with the support and the enthusiastic participation of Rotary worldwide, we anticipate changing thousands and thousands of lives for the better. And as I said, that's really what it's all about.
Well, thank you very much, team. We are excited about the next step of this project. As Mr. Jarrett said, we're going to finish up the socket and be back in a few hours with the first fitting. Stay tuned.